All right, so we've been doing some input and output already. I described CIN and Cout as the standard input stream and the standard output stream. Uh, Here's a little more information about that. Basically, an input stream is um, a way to get external data from the computer at large into our program. Um, we'll do a lot of talking about these as streams of characters. That's not the only way data can be represented in a data stream, but that's the easiest way for us to think about it. And an output stream is a way to get data from our program out to the computer at large. Uh, in Chapter 6, we'll talk about doing the things that we do with streams with files instead of the keyboard and display, but the principle is the same. So in this statement, we're saying the Cout, the standard output stream, uh, is going to be receiving data. So we're inserting data into the output stream, and the data we're inserting is the number of bars, and we can actually string multiple insertions together with this, that apply to the same stream. So in addition to the number of bars, we'll actually also put this C-string literal space candy bars and a new line. Same as doing it as two separate statements. It's just a little more convenient to do that. And we can even put calculations in there if we wanted to. So that's the insertion operator, and it works with the output stream Cout. I already said that a statement doesn't end until we get to the semicolon. So if you have a lot of things that you're stringing together, you can type them on separate lines and the compiler won't care. It just sees a new line as more white space, as if we had just typed a space there. But it will make it easier for a human to read it. Even though we type a \n, that seems like two characters. It's two characters to us, but the backslash is actually an escape sequence, or the start of an escape sequence, and it generates a single character called the new line character. The include at the beginning of our program is the include directive, and it basically causes the contents of the IOStream library or whatever library we're including as part of our program. Since CIN and Cout are defined in the IOStream library, then we need to include those in order to be able to use it. And the using namespace std tells the compiler that we're going to need to refer to things that are declared in the std namespace, because IOStream declares its variables in that namespace. So that's another thing that we have to do in order to be able to use CIN and Cout. Here's some more information about escape sequences. The backslash begins the escape sequence. The next character is going to be how we interpret the escape sequence. Um, you can particular things that are defined for a compiler, like new line, tab, alert, backslash, and double quote. There are some that are undefined, and you can actually use an escape sequence to create any character or byte of data that you need by using a numeric code, but they don't cover that in the book. So here's some sample code, display 2.4, using another data type, the character data type, or char. Oh, here's something new they've added to the text this year. C++ 11, the 11 revision to the C++ standard has some new things that they've put in. They're going to talk about those from time to time in the text. Raw string literals allows us to type in a bunch of stuff that we might otherwise have to use a lot of escape sequences for in order to enter it. And so here's a more convenient way to enter those without having to put a bunch of put multiple backslashes together. If we were to do this code using backslashes, we would have to have 2 backslashes in a row to represent each of the backslashes in the C string. And we can use either the \n or the ENDL for a new line. If you're already typing a literal C string, in quotes, it's going to make sense just to use the \n. If you are not in the middle of a literal C string, then it will probably make more sense to use the ENDL, although it would be the same number of characters as a double quote \n double quote. ENDL is slightly easier to type. And you should always end your program with a \n, a new line character, one way or the other. Sometimes when you're outputting data that is a real number, in other words, it has a fractional part with a decimal place in it, you're going to be concerned about how that number is formatted. For example, you're trying to make it look like dollars and cents. You would like to have some number of places before the decimal followed by 2 places after the decimal. Because that's the way dollars and cents is written in English. So, if you just output the contents of your variable, you would like it, in this case, the variable has the value of 78.5. You would like it to say 78.50, meaning $78.50. But it might actually output 78.5 with a bunch of zeros after it, more likely 78.5 with nothing after it, or if it decides to use E notation, 7.85 E01. In order to override what the default that the compiler is going to choose for you, you can use this sequence: cout.setf iOS fixed, cout.setf iOS show point, and cout precision 2. Fixed, basically this is the set flag member function of the cout stream. We're telling it to have a fixed decimal point, and we want it to show the decimal point in all of our output, and we want to have 2 digits of precision following the decimal point. Yes.
So you use all 3 of them together?
Yes. You do all 3 of them together, and any real number numerics that you output to cout after that point in your code will be displayed the way you specify here. And so here's what the output would be for our sample program after using that code. Chapter 6 will talk more about that. But whatever value you put in precision is the number of digits after the decimal that will be displayed in your output. We also get input with CN, and we can use whatever type of variable we need for our input. We can actually input multiple variables in the same line. It's going to look for that many variables, although it may not look for it exactly the way you think it will, because if the parsing that the CN does finds a white space, it's going to stop and expect the next thing that you typed in your input to be another value. So I could actually put 2 values on the same line in this program. When I'm running this program, it will put them in separate variables. And something that's kind of annoying that happens with CN is if it's expecting a numeric, an integer, or a double, and you type something that's not numeric, then it will fail to process properly, and your program will not be able to recover from that. Later we'll learn how to control the input ourselves so that that doesn't happen to us if somebody accidentally types bad data. When you're getting input from a user, it's a good idea to prompt the user for the data you want. Basically all that means is you are putting information on the screen that tells them what your program is expecting. The other thing you need to do is output the data that they input. We call that echoing the input, and that allows the user to make sure that you got the information they typed in correctly, and that's what your computation was based on. If you don't put a new line in your output statement, the cursor and the prompt will remain where you left it. So you can have somebody type data that will appear on the same line as the prompt that you gave them, as in the example here. And when they hit enter, it will generate a new line and whatever you output next will go in the following line. So, Ms. Moody, can you give me an output statement that will produce this message, the answer to the question of life, the universe, and everything is 42, except the answer to the question of is on one line and life, the universe, and everything is on another line.
Okay. Could you see out the arrows?
Insertion operator.
Insertion operator. Quotation marks.
Okay.
You would type the answer to the question of in, and then the forward slash.
That's actually, oh, you got that reversed. It's the backslash followed by n.
And then in quotation.
Okay.
And then insertion operator. Life, I'm sorry, quotation. Life, comma, the universe, comma, and everything is 42, period. In quotations.
Okay. I would probably say we would put a new line there as well. And in fact, we didn't really have to start a new string here. By having the new line character in there, we start a new line at that point. Although it might make it easier to read if we put some of this on the next line. Okay? Mr. Rahim, number 9, give an input statement that will fill the variable, the number, which is of type int, with a number typed in at the keyboard. Proceed the input statement with a prompt statement asking the user to enter a whole number.
See out. Enter a whole number and press return. Start a new line. And see again. Underscore number.
All right, I typed the insertion operator for you, but after CN, you're going to need an extraction operator. Since we declared it, since we didn't declare that variable, it's telling us there's a problem there. But okay. Now we didn't have to put a new line here. We could have said colon and then let them type their data there at the end of the line that we output. Either way works depending on the situation. Mr. Nelson, if we want to ensure that a number of type double will be output in ordinary notation with 3 digits after the decimal point, what are we going to need in our code?
Say CO
Set F.
OS 2 colons. Next. Same thing with show point. Yeah, decision. So parentheses, 3.
Okay. Ms. Hargrove, you write a complete program that writes the phrase "Hello World" to the screen and nothing else?
Yeah. Number sign include. So look at the left arrow, IO string. Right arrow. Next line using namespace standard. Semicolon. Next line int name. Close parenthesis. Opening bracket code bracket. Cout. Insertion. Parenthesis. Hello world. Backslash n. Close parenthesis.
Double quotes rather than parentheses.
Return 0. Semicolon. And next line close bracket.
Okay. And Mr. Year, give number 13, give an output statement that produces the new line character and a tab character.
Backslash n backslash t.
We're going to need cout. Yeah, the output statement that produces the new line character. So we need cout and the insertion operator and the double quotes. That's the output station that produces the new line character and the tab character. Backslash n and backslash t would be the escape sequences for new line and tab. All right. Data types and expressions. Int and double are 2 different data types. Internally, they're stored in different ways, and conceptually, to us as humans, we think 2 and 2.0 are the same thing. In the computer world, they are not. So there are various ways that we need to distinguish those things. For example, if we're writing literal constant values and we use all numeric digits with no decimal places, those literal constant values will be integers. And if we use decimals, then those values will be doubles or real numbers. And there's some information about the difference between double precision and single precision. We can also write our doubles or floating point numbers in scientific notation or double or floating point notation. Scientific notation or actual scientific notation uses superscripts. So 3.67 times 10 to the 17th power is what we would say in scientific notation. The equivalent thing would be expressed in C++ using E notation. The E takes the place of the times 10 to the power. So 3.67 E17 is the same as 3.67 times 10 to the 17th power. Or 367 followed by 15 zeros because we took 2 decimal places with our 67. And the same thing for negative exponents, meaning that we move the decimal place to the left. So 5.89 times 10 to the minus 6, we move the decimal point 6 places to the left. And we get the equivalent number. E notation is just easier for us to type. We don't have to figure out how to make a superscript number. There are some other number types. Long double, long int. Just long by itself is the equivalent of a long int. Basically, those are ways of storing larger values for integers and values with more precision and larger values for doubles. So we have integer types and floating point types. And here's a handy table that talks about some of the data types, some of the numeric data types. And typical ways that they're stored in memory. The C++11 has some additional types. There's the auto type that allows us to make a value that we don't have to decide the type on ahead of time. Not going to be too much help to us in here. Here's some additional fixed data types for either saving memory or using longer numbers. There is also other kinds of data other than numeric data that we can access in our programs. One of those is the character type that I mentioned earlier, char for character. And it's basically designed to hold any single character that we can type from the keyboard. They call the data that's between double quotes in code strings. It's not actually stored internally as strings. We'll learn the distinction between strings and C strings later on. These are actually C strings. But one thing that you do want to distinguish between is a character and a C string. Single quotes in literal values are indicate a character value, char value, and double quotes indicate a C string value. Not the same thing. There's also a bool type or boolean type that can have the value of true or false. And we'll learn more about that in a little bit later. There's also a string class. We don't know how to make our own classes yet, but we've already been using a class because cin and cout are class objects. And they introduce string here so that we can do some simple things with it without having to worry about the weirdities of the C string. But for instance, if you include the string library in your code, you can make a string variable that you can then assign a value to. You can concatenate multiples of them together and so forth. And display 2.5 is an example of using the string class. Again, cin is going to stop even if you're getting string data when you type a space. So if your middle name or the name of your pet was actually multiple words and had a space in it, then this code wouldn't work properly because it's going to stop when it gets to a space and store everything it found up to that point in the string. Cn, using the extraction operator, will always skip over spaces and stop when it gets to a space. A blank space of any kind, meaning either the space character or a tab or a new line. Okay, and those are known as white space. As a general rule, don't try to assign a value of one type to a variable of another type. So in this example, 2.99 is a floating point or real number, and it's not going to store in an integer variable properly. Depending on what compiler you're using, and I'm not sure what the default behavior for Visual Studio 2012, which is what we're using, will do. It may give you an error message. It may just give you a warning. But if it does let you use it, it's going to truncate the value to the nearest integer. And even if your value looks like it should be an integer, like 2.00, it's not the same as using integers. You can assign a double, an integer value to a double, and it will do an automatic conversion for you. I mean, that's acceptable. That's done fairly frequently. It's better to use a value of the type that your variable is going to be, and it's better not to use literal constants in your code at all. A character is actually internally stored as a number, a small integer, or an integer type number. And so generally compilers will allow you to set characters to numeric values. It can cause problems if somebody's reading your code later, so I'm going to discourage you from doing that. Booleans can also be assigned values from integers and vice versa. That can lead to some problems that we'll talk about some more when we get to Boolean expressions. We've talked a little bit about arithmetic, operators, and expressions before. Typically, we have an assignment. We have a mathematical expression on one side and a variable that we're assigning the value to on the other side. And those expressions are going to produce data of a type. So if we have two doubles, we add them together, they're going to produce a double. If we have two integers, we add them together, they're going to produce an integer. Something unusual happens if we have two integers and we're dividing. So 7.0 divided by 2, you would expect to produce the value 3.5. And that's exactly what we get, because if one of the numbers is a double, it produces a double result. 7 divided by 2 is a case of two integers. We're dividing one integer by another, and it's going to cause a different type of operation to happen, and that is an integer division. An integer division is going to give you the whole number resulting from that type of a division, and in this case that would be the number 3. It's going to produce an integer result, and if we're dividing 7 by 2, that wouldn't be an integer result. So it does integer division, kind of like long division, throwing away the remainder. There is another operator called the modulus operator, the percent sign. And that can be used to get the remainder of the division operation. So 17 divided by 5 is 3. The remainder is 2. 17 modulus 5 will give you the result of 2. If you're interested in what all of the operators are, you can go back to the appendices. Appendix 2 is the precedence of operators table. In addition to telling you what order operations will be handled in, it also lists all the operators that you can use in C++. So here's some more examples of integer division. And they warn you not to use integer division with negative numbers. If you don't want your expression to be evaluated in the order of precedence, following the rules, multiplication comes before addition and so forth, you can always override by using parentheses. The parentheses will cause operations to be grouped the way you group them within those parentheses. And here's a table demonstrating how you would convert a mathematical formula from traditional textbook expression to C++ expressions. And here's a warning about using whole numbers in division. Again, you shouldn't be using literal constants in expressions in your program anyway, but if you do, you're liable to run into problems if you happen to express something as an integer and you weren't expecting to get integer division. So, Mr. Wilson, number 15, convert each of the following mathematical expression or mathematical formulas to a C++ expression. So we've got 3x.
Should just be 3 times x.
3 times x. Okay. 3x plus y.
Parentheses 3 times x and parentheses plus y.
Okay. In that particular case, the rules of precedence say that multiplication goes first. So you would have the same results if you left off the parentheses, but it's not a bad idea to use parentheses. It makes your code clearer. We know what your intention is, and you don't have to worry about having memorized all of the rules. X plus y over 7.
Parentheses x plus y divided by 7.
In this case, we did need the rule, the parentheses, because by the rules, we would do the division first. And the final one, 3x plus y over z plus 2.
Do a double open parentheses.
Okay.
3 times x, closing parentheses, plus y, other closing parentheses, divided by parentheses z plus 2.
Okay.
So Herman,
Yes.
why is it a Z equals like why not?
Well, I just put that in there to make it a complete statement in C++. Uh, what we're interested in is the expression part. But just putting an expression on a line by itself is not a valid C++ statement. So I wanted to make it look more like an actual C++ statement that we were writing. Okay? All right, Mr. Saravi-Rodas, what is the output of these program lines if you embedded them in a program and we had already declared all these variables and their type character or char? Any idea?
Start out with C out.
Cout is going to cause the data to come out on our screen. So what data is going to come out on our screen?
Oh, the A insertion operators, and B insertion operators, C for
So you think it's going to say A,
is it a B? Well, A equals B, it would be B.
all right. So we'll have B,
B insertion C and then insertion operators A and A again.
okay, so insertion operators just mean we're sending the data or inserting it into the output stream. So when we say what is the output, we want to know what the result is, what ends up on the screen. And so in this case, what's going to end up on the screen is whatever the contents of the variable A are, which you said is B, so that's correct, so B, followed by the contents of B, which is C, followed by the contents of C, which is A, except A is a variable holding a value of B, right? And then the literal value C. So the output is going to be BC, BC. Does that make sense? Okay. Those are variables. Although the way it was written, you might expect it to say ABC. Those are variables, and we're concerned about what they have inside them, what values they're holding rather than the names of them. All right, Ms. Hernandez, how about number 17? What is the output of that program going to be? Okay, so the output is everything that follows the insertion operator when we're going into a out, cout. So what is going to be output? One parentheses 1/3 times 3 is equal to, okay, so we're not storing this as a string. This is an expression. 1 divided by 3 times 3, we have to evaluate that expression, or the computer is going to evaluate that expression. Okay, you're saying it's going to be 1. Okay, 1 divided by 3 is what? Okay, if these were doubles instead of integers, 1 divided by 3 would be 0.3333, and then times 3 would probably be close to 1 maybe, but the problem is they're not doubles, they're integers. And using integer division, 1 divided by 3 is 0. So 0 times 3 is 0. Okay? So we would call that a logic error, because clearly if we were assigned that as a math problem to do, we wouldn't expect 1 divided by 3 times 3 to be equal to 0. But integer division is going to make that result.
What if it was a double?
If either the 1 or the 3 was a double, so if I had said 1.3 divided by 0, then it would have done floating point division, and it would have probably come out to be 1.0 or 0.99999 or something close to 1 at least. But because of the fact that both of those numbers are integers, it's doing integer division. All right, let's go on. More assignment statements. In addition to just doing an assignment, we can do an assignment with another operator. So in other words, plus equal, minus equal, times equal, and it saves us a little bit of typing. Count plus equals 2 means add 2 to whatever is currently in count, or in other words, count equals count plus 2. Shortcuts. People that were writing C++ liked shortcuts. All right, so far we've been doing things sequentially. We've been using sequential programming structures, and that is fine as far as it goes, but sometimes that's not good enough, and so we need to be able to control the flow of the process instead of just doing every step in order, one after the other. we need to be able to choose between alternative actions or go back and repeat things. So let's start with a simple branching mechanism that allows us to choose between two alternatives. For example, if we wanted to be able to calculate how much someone was going to get paid, if they work 40 hours or less, they always get the standard rate. But if they work more than 40 hours, they get 1.5 times the standard rate. And as long as they're only working 40 hours or less, we have a simple formula that we can use. But if they're working longer, we need to apply another formula. You might say, well, why don't we just apply the other formula all the time? Well, the problem is, if they work less than 40 hours, then we would end up subtracting money from their pay, and that wouldn't work out correctly. So our branching mechanism, or the simplest branching mechanism, is the if-else. We have an if that goes with a Boolean expression. A Boolean expression evaluates to either true or false. Hours is greater than 40 is going to evaluate to true if whatever value is in hours is larger than 40. And if the expression evaluates to true, we'll do the if part using the more complex formula. If it's false, we'll do the simpler part, the else part. And each of those parts can be one statement. It will either execute the if statement, the statement in the if clause, or the else statement, the one that's in the else clause. Sometimes we'll need to execute more than one statement. And in order to do that, we actually create a code block with a set of curly braces. In the book, they refer to this as a compound statement. But really what we're doing is we're using a block of code to take the place of a single statement. And we can do that anywhere we can have a statement in C++, we can put a block of code and have multiple statements in that block of code. And as you're starting out, it may actually make sense for you to use those brackets so that you don't have to worry about whether you have multiple statements or not. First of all, however, we have to deal with a Boolean expression. A Boolean expression typically will have some kind of a comparison in it. Mathematically, we have equal, not equal, less than, greater than, and so forth. And we have equivalent C++ notation for them. The equal to expression is the one that's a little bit tricky because in math we just use the single equal sign. In C++ we use the double equal. You remember what the single equal means in C++. It's always the assignment operation. And that can get us into trouble if we try to use it in the Boolean expression. We can also combine these comparison operations together to make complex Boolean expressions by using AND, the double ampersand, and OR, the double vertical bar. An AND expression will be true only if both of the subparts are true. So if this statement is true and that statement is true, then the ANDed statement will be true. Whereas an OR will be true if either of the subparts are true. There is also a NOT operator, which we can use to negate our expression. Generally, it's best to avoid the NOT operator if you can. So for example, they say here, if not x is less than y, could be written as if x is greater than or equal to y. So you should probably rewrite any statements that you think need a not in them at this point. You can also leave off the else part of an if-else statement, and we refer to that as an if statement. A single alternative if statement, basically it means that this statement is optional. It's only going to happen in certain conditions. In math, you can also do something like y is x, or x is less than y is less than, or, I'm sorry, x is less than z is less than y, meaning that z is between x and y. And if you try to do that in C++, C++ is unfortunately going to combine those in a bad way. So in order to correctly ensure that z is between x and y, we need to combine x is less than z and z is less than y with an AND operation. Here's some more information about using an equal sign, an assignment operator instead of an equal to operator. And a way to avoid letting the compiler skip over that. They talk about compound statements, which are really statements being replaced by a block of code. Here's some more self-test exercises. Mr. Brantley, number 21, write an if-else statement that outputs the word high if the value of the variable score is greater than 100 and low if it is at most 100.
So it'd be if parentheses 4 greater than 100. You put, I don't know, you put a semicolon on the end of it.
No, you do not. That would introduce a null statement.
If the you see out and the parentheses high forward slash n.
Okay. Insertion operator, backslash n, and these are double quotes.
Else for less than, oh, sorry, for parentheses, for parentheses for less than greater to parentheses see out and less than parentheses slow
Okay. This part in here is wrong. We don't put a Boolean expression on an else statement, but that does illustrate the alternative value. If score is not greater than 100, it must be less than or equal to 100. So else is just the other case, and it is never going to have a Boolean expression with it. All right, let's go on. Oh, number 27, Ms. Moody. There's some cout statements embedded in if-else statements. And they say if 0, if 1, if minus 1. Do you have any idea what result that would produce?
If it's 0, if what's 0?
Ah, this is a case of converting an integer to a Boolean. So C++, if you put an expression in where it's expecting a Boolean expression, and you actually have an integer value there, it will convert it to Boolean for you, and maybe not necessarily get what you were expecting. False, or the value 0 converts to the Boolean value false, and any other integer will convert to the Boolean value true. Alternatively, true will convert to the integer value 1, and false will convert to the integer value 0. So, not that I expect you to write if statements this way using integers and Boolean expressions, but you may find some in code somewhere. So that's how that works. In addition to branching, we like so the decision structure, we also may need a repetition structure. And we do repetition with a loop mechanism. The simplest loop mechanism in C++ is the while, or while loop. And the while is again while followed by a Boolean expression. And what that means is it's going to perform the body of the loop as long as that Boolean expression evaluates to true. So in display 2.12, while countdown is greater than 0, it's going to evaluate that expression. If it's true, it will execute the body of the loop. And a while can have a single statement, just like an if or an else. You'll generally see it with these braces indicating the body of the loop, because in order for the loop to complete, something has to happen to make this expression evaluate to false. So if it's true, it does this, and then it tests the expression again to see if it's still true. And as long as it's still true, it will continue to execute the body of the loop. So that means if the expression is not true to begin with, for example, it says how many greetings do you want, and you enter 0, that expression starts off false. So you're not going to get any hellos. You can have a loop whose body executes 0 times, a while loop. Since we want the loop to progress toward a resolution, one of the things we may do is increment or decrement numbers. In other words, increment, add 1, decrement, subtract 1. And so there's a specialized operation for incrementing and decrementing. The plus plus increments and the minus minus decrements. So in this case, instead of saying countdown equals countdown minus 1, we could have just said countdown minus minus, or countdown decrement. That's the decrement operator. The plus plus is the increment operator. And those are used fairly frequently in looping operations. I said we try to make the loop progress toward a resolution. If that doesn't happen, we'll end up with what's called an infinite loop. So here's a case where they started with a value of 2. They're testing for the value of 12 while x not equal to 12. and they add 2 each time, so we expect it to say 2, 4, 6, 8, 10. When it gets to 12, it stops. However, if they initialized x to 1 instead, it would never hit 12. And it would just keep going up and up until some external force stopped it. That's an infinite loop. And one way to externally stop that would be to use the Control C to kill the program. We could also use the task manager, or if we're debugging, the break key, Control break. Mr. Rahim, number 28, what is the output produced by the following code when embedded in a program? X equals 10 while x is greater than 0. Output x, x equals x minus 3.
This here.
Well, it would start with 10. 10 is greater than 0. We output 10. We then subtract 3. What would x be after we subtract 3 from it? 7. Is 7 greater than 0? So we continue to loop and we output x, which is, we just said it was 7. Okay.
7 minus 4.
4, which is,
4
okay. So 10, 7, 4, 1. Once we subtract 3, we'll have negative 2. Negative 2 is no longer greater than 0, so we stop repeating. Mr. Nelson, what if we replaced the greater than sign right here with a less than sign? Sorry? This would be false, which would mean we would not execute the body of the while loop, so it would not output anything. It would still, the program would still run, it just wouldn't output anything. Okay? Style. Typically, The style I expect for your programs will be the style they use in the book, which is mostly, or at least partially, enforced or suggested by the way the editor works, indenting lines between curly braces, and uh, but also they want you to type your curly braces on separate lines by themselves and make your lines not be too long or run together code. Um, However, we're going to now encourage you to start using comments. Here's a comment at the beginning of this sample code. 2 forward slashes indicate the start of a single line comment that you can use at the end of a line. And the compiler is not going to pay any attention to those comments. They're only for a human reading your code. If you need to write a comment that will span multiple lines, you have another form, which is slash asterisk and asterisk slash to end it. So we have a beginning of a comment and the end of the comment. And sometimes this can be useful for commenting out some code when you're trying to figure out what's wrong with it. Naming constants. I said that it's not a good idea to have literal constants in your code, like a number that you just have somewhere in your code that's significant to your program. And they have the example of the number 10 for the number of branches at your bank, and maybe you have to refer to that number 12 times in your code, and then you open a new branch and you have to change all those 10s to 11. But what if you miss one? Or what if there's something else that has a value of 10 and you didn't intend to change it? So we can have a variable with a value in there. Problem with a variable is it can change in our code. So here's a new modifier that we can use, the const modifier. Now we can declare something as a const int, and that is the beginning of what's called a declared constant. A declared constant is a constant that has a name that is declared at some point in our code, and since it's a constant, it cannot be changed by our code anywhere. We don't have to worry about it changing while our program is running. But if we need to change the number of branches at some point, we can change it once in our program, and all of those places where it needs to be referenced will change. By convention, we capitalize all of the letters in a declared constant so that someone reading our code will see immediately that we intend that to be a constant. Yes?
What is that different
The only difference is that when you use a constant, when you're declaring a constant and you use the const modifier, it can't be changed later. Okay, so we're initializing it, and in fact, since it's a constant, we have to initialize it. But we're also ensuring that it never gets changed while our program is running. So let's talk about your assignment. We're not going to meet for class next week, but I would like you to go ahead and turn in your assignment at the usual time next week. I'm not kind of holding your hand this week. We're going to see how you do on your own. But I will be reviewing what you submit. And I may or may not give another assignment or give an assignment for Chapter 3 next week. So I would suggest that you go ahead and read Chapter 3 in case we have an assignment for the following week. But I want to see how everybody does on the Chapter 2 assignments. So try to get them in before next Wednesday, and depending on how well everybody's doing, I'll either be giving you feedback and let you resubmit it, or we'll continue on with Chapter 3. The assignment is going to be assignment 2, which is the sweetener problem. I've copied the text from the book. A government research lab has concluded that an artificial sweetener commonly used in diet soda pop will cause death in laboratory mice. And your friend wants to drink diet soda pop to lose weight, but he doesn't want to die. So, theoretically, you could have the same ratio of sweetener to body weight that killed the mouse would kill a person, theoretically. Probably doesn't really happen that way, but that's the premise we're going by. So your program is going to tell him how much diet soda with that sweetener that he can drink before it kills him. So you'll have to take an input of how much artificial sweetener killed a mouse. For example, they said 5 grams killed the mouse. The mouse was a 35-gram mouse. Probably a little bit probably on the high end for a mouse, but you're going to have to figure out the ratio. The third thing you're going to input, so the amount of sweetener, the mass of the mouse, and the weight of the dieter. And we want this to be safe for the dieter as he's losing weight, so the target weight of the dieter, how much he wants to weigh at the end. So you're going to figure out how much sweetener your dieter can have at his target weight to be under the amount that killed the mouse. Yes?
Is the only constant you want is to declare the percentage?
No, you should declare a constant for as many things as you need one. And in fact, in my instructions, you see converting your data into a common set of units, and maybe for calculations and then converting before displaying. You may need constants for all those conversion factors. So your diet soda is going to have 1/10 of 1% artificial sweetener, or in other words, 0.001. And we're going to allow the calculation to happen as many times as the user wants it to. So you're going to need a loop. All right, so you'll have variables for the input data, the mass of the mouse, the mass of the sweetener that killed the mouse, the weight of the dieter. You're going to need a loop to allow us to repeat. I want you to accept and report your human factor data in user-friendly terms. So the mouse weight or mouse mass and the mouse or the amount of artificial sweetener are given in grams, but the dieter's weight is going to be in pounds. And the amount of soda he can consume needs to be in something that's familiar to him as well. If you give it to him in grams or even pounds, that's probably not going to work very well. He needs it in liters or cans. You're going to have to figure out how to make those conversions. The grading criteria, the grading criteria right here. We need your executable file, your source code file. It needs to compile and run when I get it. You need to use the correct style. You're going to need a declared constant for each conversion value you use in all caps. Make sure you use the correct conversion value. Echo back the data to the user. So, in other words, I entered the amount of sweetener that killed the mouse, the number of grams the mouse massed, and the target weight of the dieter. And your output should be something like, if 5 grams of artificial sweetener killed a 35-gram mouse, then X liters of diet soda would kill a 100-pound dieter. It needs to repeat. All your calculations, you use floating point values so that you don't have any accidental integer division. You should produce correct results for a lethal dose for a human. And you should give me everything in reasonable units. Grams for the mouse, pounds for a person, and liters or cans or ounces or whatever reasonable units you choose, as long as they seem reasonable. And you should not have any runtime errors. Any questions about any of that at this point? All right, so submit your program to the Dropbox. I'll review it. I'll either give you a grade. Well, I will evaluate it, and you'll get a grade, and I will tell you what, if anything, is wrong with the program you wrote. And I'm thinking at this point I'll probably give you another opportunity to revise your code and submit it again. But go ahead and read chapter 3 in the meantime. And when we meet again, September 10th, we will have a quiz over chapter 2, and we will cover chapter 3, and we may have a follow-up on this homework assignment.
Will we have the quiz 3 on that day too?
Probably will not have the, yeah, no, we won't have the quiz on chapter 3 on the 10th. So we'll save the chapter 3 quiz for the next class. Any other questions? All right. Well, if not, then I will see you in 2 weeks.